Hi, everybody. Welcome to part two of area of irregular polygons. And I know our last lesson was very long, so this is going to be shorter and just recap what we did. I am just using plain paper, so you need paper and you're going to need your calculator. But pause me if you don't have those things. All right, so last time we were together, we talked about two different ways to look at the area of regular polygons, right? Regular polygons, meaning that all the sides and all the angles are the same or congruent to one another. So you could use 1/2 perimeter times apothem, or you could use the area of a triangle times the number of sides in the polygon. And if you look back at your notes, we took our polygons and we divided them into congruent triangles. So that's why we could find the area of a triangle. So I just made some notes for you to help you go through like a systematic way to do this. So the first thing you're going to do is decide which formula you're going to use. I really like this one. This is my favorite because it makes sense, right? And we know we're very familiar with the area of a triangle, and then you can count the number of sides. So it's not that difficult. But either formula that you choose, the first thing that you're always going to do is find the central angle measure, because the central angle measure is going to help you work inside that polygon on that triangle to find the apothem and the side of the polygon. And then the second thing is you're going to draw that triangle and you're going to create the apothem or the height of the triangle. They are both the same thing. The apothem and the height are absolutely the same. And that is going to bisect your central angle measure. So you're going to cut it in half one more time. And then our job is to find the apothem or the height and the side of the polygon. So you can say the apothem is the same thing as the height of the triangle, and the side of the polygon is the base of your triangle. So those two things are critical. We went over our 30, 60, 90 degree triangles. I've also loaded a video that you can just watch under topics. So if you don't remember the 30, 60, 90, you can go back and review it. And then our trig ratios are also going to be super helpful. So remembering our SOHCAHTOA, our 3 trig ratios to solve the triangles. And so then once you find these two, you put them into the formula that you like working with, whichever formula it is, and multiply. And you're going to see, I'll do the first one tonight with both formulas so you can see what it looks like. But looking at the first problem that I have for you is we are going to find the area of a regular dodecagon with a side length of 8 centimeters. So first thing I want to know is how many sides does a dodecagon have? Hopefully you said 12. Yes, so the number of sides, or our n value, is 12. We have 12 sides on a dodecagon. Now, I wouldn't suggest trying to draw a dodecagon unless you're feeling very ambitious and maybe you're very artistic. I am not going to do that, but I know that inside the dodecagon, there are 12 congruent triangles, all right? So I'm just going to draw one triangle to represent the 12, and it doesn't have to be perfect. You know, it's just a triangle. You just have to be able to work with your triangles. So here's my one triangle, all right? Now, the first thing that we're always going to do is we're going to find the central angle. And so if we were to draw all the triangles, they would be making a full circle up here, right? All their angles up together. And so we would do 360 divided by 12. And when we do that, we get 30 degrees. That's a pretty nice number, isn't it? So that means that this angle measure up here is 30 degrees. Now, here's the thing. We are going to draw the height or the apothem. And when we do that, it bisects that central angle on our polygon. So that 30 degrees is now going to turn into 15 on each side. All right. And then we were also given the side length is 8 centimeters. So this whole entire side of my dodecagon is 8 centimeters. That's the base of your triangle. So the only thing that we need to find in this problem is the height or the apothem. So you should be looking at this triangle and you should be saying to yourself, okay, I've got the 15-degree angle. I need to find my height or my apothem. I'm going to call it A. And how big, right? This 8 centimeters has split this base into congruent pieces, right? So these are 4 centimeters each. So please tell me which trig function is going to help us get the job done to find our height or our apothem. All right, so let's see if you pick the right trig function. We have got the opposite side and we're looking for the adjacent side. So hopefully you chose tangent to find our apothem. So if you recall, tangent theta equals the opposite side over the adjacent side. So our angle measure is the 15, and the opposite side is the 4 centimeters, and the adjacent side is what we're looking for, our apothem. All right, so cross products, my friends, right? A times tangent of 15 equals 4 centimeters. And remember, this is multiplication. We're going to do the opposite to undo that process. We're going to divide by the tangent of 15 degrees on both sides. All right, so tangent of 15 over tangent of 15, that is a 1. So we have A equals, and then you are grabbing your handy dandy calculator. And we are going to do this 4 centimeters divided by the tangent of 15 degrees. All right, so we are getting 14.93 centimeters. All right, so that's our apothem or our height. And now we have everything we need to use either formula. So for the first formula, my favorite is just doing, for the total area, I like doing the number of sides. So decagon, so the number of sides is 12 times the area of our triangle. Well, that's 1/2 the base, which is the 8 centimeters, times the height, which we just found is 14.93 centimeters. All right, so go ahead and put that into your calculator. Now, if you look at this, we have 1/2 of 12 is 6, and 6 times 8 is 48. So it is 48 times 14.93, which is a big number, 716.64 centimeters squared, because it's area. All right, so that's one way to do it, by looking at the different triangles that are in your dodecagon, 12 triangles. The other way to tackle this problem would be use the formula of 1/2 perimeter times apothem. So I just want to show you what that looks like again. And remember, we're using all the same information that we already gathered. So 1/2, and perimeter is one side times how many sides there are, right? So we have one side at 8 times the 12 sides, and then we have apothem. Right? And look at the numbers that we just gathered. We have 1/2, and there's the 1/2 from the area of our triangle. We have the 8. Here's our 8 in here. That was our base of our triangle. The 12, that's the number of sides. And then the apothem is the same thing as the height. So you can see it's all the same numbers. You're putting the same numbers down to multiply together. And so when you multiply those out, lo and behold, you will get the same answer. So you just need to decide which formula you want to memorize and which one you want to use. All right, so I am going to go to number 2. Number 2, we are going to find the area of a regular nonagon with an apothem of 5 millimeters. All right, so nonagon, How many sides does a nonagon have? Well, it's the only n polygon that we have, and so it does go with 9. The n sides with 9, right? So we've got 9 sides, and to find the area, we're going to multiply that by 1/2 base times height. I'm using this one. It's my favorite. Now, here's what I want you to do. You're going to draw the triangle. And you're going to find that central angle. And you're going to find as much as you can about the area. So I want you to pause me and do your due diligence to try to find the area of this nonagon by yourself. All right, let's see how you did finding the area of the nonagon. So first thing I told you is let's start with the central angle. So we're going to do 360 degrees divided by the number of sides. There's 9 sides. We get a beautiful little number, 40 degrees. So this top angle is 40 degrees. And when we drop our height, our apothem, it's going to make 20 degrees on each side. All right, so it gives us the apothem measurement, right? Did you guys read that? The apothem measurement is 5 millimeters. So this is 5 millimeters right here. So we have the height of our triangle. We need the base. And so you should have gone searching for just this side of the triangle. We're going to call that X. And remember, we're going to double it to find the whole thing. This is going to be 2x. When we find the side of our nonagon. All right, so which trig function are we going to work with? I hope you use tangent. From the 20 degrees, we have the opposite. We're looking for the opposite side, and we have the adjacent side. So that's going to be tangent theta equals the opposite side over the adjacent side. So I've got tangent of my angle, 20 degrees, equals the opposite, the x, over the 5 millimeters. All right, cross products time. We've got 1 times x equals tangent of 20 degrees times the 5 millimeters. So to your handy dandy calculator, be careful pressing in the information and double check your display to make sure it's what you want. I have messed up terribly just by not paying attention. So watch your display. So tan of 20 degrees times the 5. And we are getting x equals 1.82 millimeters. Now here's the thing. This is half of the side, right? So we need to go ahead and times it by 2. And we're going to use the whole side, which is 3.64 millimeters. That's what we're going to use, and that's what we're going to put in our formula for the base of our triangle. Alrighty, so we're almost done. Because they gave us the apothem in this one, we just had to find the base. We're almost home free. So we're going to do for our area 9 times 1/2 the base, which is 3.64, times the height, which is 5. All right. So we're going to do, let's do 4.5 times 5 times 3.64. Voila, 81.9 millimeters squared. All right, is that what you had? I hope so. And here's what I'm going to tell you. Practice makes perfect. So when you go back online, you're going to see I've given you a little bit more homework on these. So make sure you get that done. And then there is an assessment to review your homework. All right. Bye-bye.